is lesson 8-7, slope-intercept form. The slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So this is just a specific form of the equation of a line. And we see that in this form, m is the slope, b is the y-intercept. So in this example, y equals 3x minus 5. The slope is 3, and the y-intercept is negative 5. And the graph to the right of that shows that exact equation. So we can see from the graph that the slope is 3. So if you pick 2 points on the graph, the slope is up 3 and over 1. So the slope is 3. And then we also see that the y-intercept is negative 5. Here's the y-axis. This crosses the y-axis at 0, 1, 2, 3, 4, negative 5. So that is the y-intercept, or b. Okay. The nice thing about the slope-intercept form of an equation is that you can see both of these things very easily from the equation. And as you can see from the graph, those are very helpful things to be able to identify. We can tell exactly where this line is supposed to go from the y-intercept and the slope. So this is just a very useful way to have an equation written. So let's do a couple examples. Example 1 says to state the slope and the y-intercept of the graph of each equation. So for A, we have y equals 1/2 x plus 3. Well, this is in the form y equals mx plus b. We have y equals, and then a number times x plus another number. So from here we can easily see that m is 1/2. And b is 3. This is the slope. This is the y-intercept. For part B, we have the equation negative 4x plus y equals negative 10. Now be really careful here, because notice that this is not in the form y equals mx plus b. So we need to first change this to that form. So in order for it to look like y equals mx plus b, we need to have y equals something. And here we have negative 4x plus y equals something. So we want to get the y by itself, so we'll add 4x to both sides. So we have y equals, and you can write this as negative 10 plus 4x, but because we want the whole equation to be in this form so that it says y equals mx plus b, we actually want this 4x to be at the beginning. So the 4x is added, so it's positive, so that's 4x, and then we have a minus 10. Okay, now this is in the form y equals mx plus b, and now we can see that the m, or the slope, is 4, and the y-intercept, b, is negative 10. Okay, so for the try it yourself problems, you're going to do the same thing. Make sure it's in the form y equals mx plus b first, and then you can identify the slope m and the y-intercept b. So go ahead and pause the video, work through those 4 try it yourself problems, and when you're ready to check your answers, press play. Okay, for A, the slope m is 3, and the y-intercept b is 1. For B, the slope m is negative 2, and the y-intercept b is 0, because this is like y equals negative 2x plus 0. For C, you should have rearranged this so that it was solved for y, so that it looks like y equals mx plus b. So then you should have gotten m is negative 6, and the y-intercept b is negative 3. And then for the last one, here m is -1, and b is 5. Okay. Well, mainly what slope-intercept form is useful for is to actually be able to graph a line. So this is one way that you can create a graph of a line if it's in slope-intercept form. This is one of the easiest ways to graph a line. So if I wanted to graph y equals -3x plus 6 using slope and y-intercept, I would first identify the slope and the y-intercept. So here, again, think y equals mx plus b. So we can see that the slope m is -3. And the y-intercept b is 6. Alright, the first thing of these two that needs to go on the graph is the y-intercept, because the slope really only tells me how 2 points are related. It doesn't actually tell me something that I can immediately put on the graph. The y-intercept, however, is a specific point on the graph, so I can start by plotting that. So if we know that the y-intercept is 6, the line has to cross the y-axis at 6. So that is right here. Okay, now from here, the slope tells me where to go next. So think of this as a fraction, as -3 over 1. And remember, slope is rise over run. So from this point, I know that I can rise -3, so down 1, 2, 3, and then run 1, and because that's positive, we want to go to the right 1. So there's another point that would be on this line. And we like to make 3 points whenever possible, it just makes a nicer line. So from here we'll do the same thing again, down 3, to the right 1. And now we can connect those 3 points to make a straight line. And this is the graph of the equation y equals -3x plus 6. Okay, so you're going to do the same thing. Remember, you want to identify the slope and the y-intercept. Start with the y-intercept first, and then use the slope to find 2 additional points. So do the same thing for the try it yourself problem. Pause the video, work through that problem, and graph that line. And then when you're ready to check your answer, press play. Okay. This line should look like this. There we go, that's better. It should have a y-intercept of -2 and a slope of -1. Down 1 to the right 1, down 1 to the right 1. Okay. So that is part of what we use slope-intercept form for. It makes it very easy to graph the line and see exactly what that looks like. Okay, let's take a look at lesson 8.8, writing linear equations. So in this section, we will basically be writing an equation to represent either a graph or 2 points or a table or some other information about a line. So in this section, you'll be given various pieces of information, and you'll be asked to write an equation. So one way to write a linear equation is to substitute the values for the slope and y-intercept in y equals mx plus b. I think this is the easiest way to do it. If you know the slope and the y-intercept, you can easily come up with an equation by substituting the slope for m and substituting the y-intercept for b. If you know the coordinates of 2 points on the line, you could also write the equation for the line using what we call point-slope form, or y minus y1 equals m times x minus x1. And this looks kind of confusing. It actually comes from the slope formula. And in this case, m represents the slope, as it does in slope-intercept form, and x1, y1 represents a point on the line. So here's the x-coordinate of that point, and here's the y-coordinate. And this will probably make a little more sense when we do an example that's in this form. This might look a little confusing right now. The table below summarizes the methods you can use to write a linear equation. And this would be a good table to keep handy for reference as far as what type of strategy you should use depending on what type of information you have. So let's take a look at the first example. Write an equation in slope-intercept form for each line. Okay, so to write an equation in slope-intercept form, I need the equation to be in the form y equals mx plus b, and I need to substitute something for m and something for b. So that's basically what I'm looking for, is the slope and the y-intercept. Well, for a, we're given the slope is negative 1/4 and the y-intercept is 7. So all I have to do here is substitute the numbers in the right places. So the slope we know is m, and the y-intercept is b. So let's just substitute those numbers where they go. So in place of m, we're going to put negative 1/4, bring down the x, and then plus, in place of b, we'll put 7. So an equation in slope-intercept form for this line, one that has a slope of negative 4 and a y-intercept of 7, is y equals negative 1/4 x plus 7. Okay, we're going to do the same sort of thing for b, except instead of being given the slope and the y-intercept, we have a graph, but we can find the slope and the y-intercept from this graph. So same thing, we want y equals mx plus b, but we need to find m and b. So let's take a look at our graph. I can see really quickly right here where the graph crosses the y-axis is the y-intercept, and this is at negative 1, 2, 3, 4. This is at the point 0, negative 4. So right there is my value for b. I can find the slope by picking another point on this line. Let's go with that one right there. And then we just have to count rise over run to find what the slope is. So rise 1, 2, 3, 4, run 1, 2, 3, 4. So the slope is 4 over 4, or just 1. Rise 4, run 4. 4 over 4, or 1. So now we'll just substitute the numbers where they belong. So we have y equals, in place of m, we'll put 1. And in place of b, we'll put negative 4. Now this looks kind of funny, so we're going to rewrite it because we don't need this 1. We can just put x. And we don't want plus negative 4, so we'll just do minus 4. Y equals x minus 4. Okay. So for both of these examples, in the first one we were given the slope and the y-intercept, and we just substituted them where they belonged. In the second one, we used what we already knew about graphs and slope and y-intercept to find those in the graph and then substitute the values. For number 2, example 2 says write an equation for the line that passes through the points 7, 0, and 6, 3. Well, there's two different ways to do this, but regardless, the first thing we need to do, no matter which method we're going to choose, is to first find slope. And this we did in section 8.6. So remember, you have this formula, m equals y2 minus y1 over x2 minus x1. So we'll label our points x1, y1, x2, y2, and then substitute the values. So we have y2 is 3, minus y1 is 0, x2 is 6, minus x1 is 7, 3 minus 0 is 3, 6 minus 7 is negative 1, and when we simplify this, this is just negative 3. So now we know that the slope is negative 3. Well, from here, there are two different ways that we can do this. The table up at the top of the page says when you're finding the equation from 2 points, to use the coordinates of the 2 points to find the slope. That's what we just did. And then this says to substitute the slope and coordinates of one of the points in, this is the point slope form. So that's one way that we can do this. So I'll call this method 1. So we have point slope form, y minus y1 equals m times x minus x1. And we're substituting values here for the m, and then for x1 and y1. So we keep this y, and then y1 is one of the two y coordinates. It doesn't matter which one. So let's go ahead and use this one, since it's already labeled x1, y1. So y1 is 0, so it's y minus 0. M, we found over here, is negative 3. And then x will stay as just x. x1 is 7. Okay. And this is an equation in point-slope form. When it says to write an equation, it doesn't necessarily mean that it has to be in slope-intercept form. So this is a perfectly acceptable answer. You also could have used the second point. So if you had done that instead, you still would have had the same value for m, but you would have used the other coordinates of the points instead. And this would be y minus the y coordinate, which is 3. And then m is still negative 3. And then x minus the x coordinate, which is 6. And these are both equivalent equations of the line. So these are both perfectly acceptable equations. Let's look at the second method. Method 2 will use y equals mx plus b. But in this case, we know the value of m. We found that already. That's negative 3. But what we would do here is use one of these 2 points to substitute a value for x and y, and then find what b needs to be. So we're going to substitute a value for x and a value for y. Let's use the first point. So what we know right now is that the equation is of the form y equals negative 3x plus b. We just don't know what b is. So let's substitute this point, 7, 0, 7 for x, 0 for y, and see what we get for b. So 0 is y, x is 7, and then we want to solve for b. So let's multiply these. This is negative 21. And then when we add 21 to both sides, we get 21 equals b. We can then take that value for b and substitute it in back here to get y equals negative 3x plus 21. So all three of these, this equation, and this equation, are all acceptable answers for this example. It just says to write an equation. It doesn't say that it has to be in slope-intercept form or in point-slope form. So in that case, you can choose either version. If it says it needs to be in slope-intercept form, it needs to be in slope-intercept form. And if it says in point-slope form, it needs to be in point-slope form. But if it doesn't specify, you can use either one. Alright, let's look at example 3. Write an equation of the line in point-slope form that passes through the points shown in the table below. Okay. Remember, when you have stuff from a table or points, like in number 2, take a look at your table at the top again. From a table, we want to use the coordinates of any 2 points to find the slope. Absolutely, the first thing that needs to be done is that you need to use the coordinates of 2 points to find the slope. But we have 4 points to choose from. Does it matter which ones we use? No. So, I really like this one where this is 0. That sounds kind of nice. And these look like nice small numbers, so let's use these 2. And I'm going to label these just again so that we don't get confused. So this is the first point, so this will be x1, y1. This is the second point, this will be x2, y2. So let's go ahead and find the slope. Alright, y2 is negative 2, y1 is 4, x2 is 1, x1 is 0. Negative 2 minus 4 is negative 6, 1 minus 0 is 1, so that has a slope of negative 6. Now in this case, this example says write an equation of the line in point-slope form, so it does have to be in point-slope form. So that's y minus y1 equals m times x minus x1. Now, it doesn't say which point to use, so we can use whatever point from the graph or from the table we want to. So let's use, I don't know, let's use this one. This is the x, this is the y. And because we're substituting those for the x1 and y1, let's go ahead and label those with 1s. I use a different color here to show that these are the x1 and y1 that we're substituting in this equation. These were x1 and y1 that we used for this formula. Could you use these instead? Sure. Could you use these 2 points instead? Sure. These two? Sure. It doesn't matter which ones you use for point-slope form. It's write an equation of the line, not the equation. There's plenty more than just one single equation. Let's go ahead and substitute what we have. So we have y minus y1, which is 10, equals m, which we found here was negative 6, times x minus x1, which is negative 1. Well, we have minus negative 1, so let's just change that right now to plus 1. Okay, and we will leave this just like this, because this is an equation in point-slope form that passes through the points shown in this table. Okay, on the next page, there are some problems for you to try yourself. And these might take a little while simply because this is a very new concept. This is something that we really haven't done before. So please take your time. Pause the video, work through those 3 try-it-yourself problems. Take as long as you need to make sure that, that what you're doing makes sense to you. Pause the video, work through those. When you're ready to check your answers for 1, 2, and 3 in the try-it-yourself, go ahead and hit play, and the video will continue. Okay, for the first one, the equation of this line is y equals 1/3 x plus 2. For B, the equation of the line shown in the graph is y equals 2x minus 3. For 2, there are a few different equations that you could have had. So I'm going to write all 3 of these. You could have had any of these 3. So if you have y equals negative x plus 3, that's fine. Or you could have had y minus 0 equals negative 1 times x minus 3. Or if you use the other point, you could have had y plus 3 equals negative 1 times x minus 6. Any of these 3 are perfectly acceptable answers. Any of those. Okay. For number 3, there are 4 different answers that you could have come up with. And again, I will give you all 4 so that you can check to see if what you had is one of those. So you may have come up with y minus 9 equals negative 2 times x plus 3. Or you could have had y minus 3 equals negative 2 times x minus 0. Or y plus 1 equals negative 2 times x minus 2. Or y plus 3 equals negative 2 times x minus 3. And if you're a little confused right now as to why there's 4 different equations, well, notice they all have a slope of negative 2. The negative 2 is the same. It's just a difference of which of these points you use. So if you use negative 3 and 9, this will be x plus 3 and y minus 9. If you use 0, 3, this will be x minus 0 and y minus 3. If you use this point, this is the equation you'll get. And if you use this point, this is the equation you'll get. No single equation there is any better or more correct than the other one. They're all equations that describe that line. Alright, let's look at one more example. Example 4 says a video game website charges a registration fee plus a monthly fee. After 2 months, the total fee is $34.90. After 6 months, the total fee is $74.70. What would be the total fee after 10 months? Alright. What we want to do with this one is think of this as an XY relationship. So we know after 2 months, the total fee is $34.90. So the fee depends on how many months you've had this membership or access to this website. So the months will be the independent variable, or X, and the fee will be the dependent variable, or Y. So same thing here. After 6 months, this is X. The fee is $74.70. That's Y. So this may not have looked like it originally, but what we really have here are two ordered pairs. The first one is 2 and $34.90. The second one is 6 and $74.70. So in order to find what the total fee would be after 10 months, what we're going to want to do is use these 2 points to write an equation, and then use that equation to find the fee after 10 months. So from here, we'll do these just like we did the previous few examples. So this is x1, y1, and x2, y2. And we will first find the slope between those 2 points. Alright, y2 is $74.70, y1 is $34.90, x2 is 6, x1 is 2. When we subtract these, we get $39.80, and then 6 minus 2 is 4. And then divide here to get $9.95. Okay. Now in this case, if we want to find the total fee after 10 months, it's actually going to be much easier to have the equation in slope-intercept form than it would be to have it in point-slope form. So, because the slope-intercept form is just a much simpler equation. So let's use that method. So we'll start with y equals mx plus b. Well, we just found the slope m is 9.95. So we'll go ahead and substitute that in. We still don't know what b is, though. We need a number to go here. Well, remember, what we can do is use one of the points for an x and y coordinate to figure out what b would need to be. So let's use this point right here. And let's substitute the values in. So y is $34.90. X is 2. And we're going to solve for b. So in order to solve for b, we need to get rid of this whole thing. So let's first multiply. 995 times 2 is 1990. And then to get rid of this, we will subtract it from both sides. And 3490 minus 1990 is 15. And remember, with this, once we have the value for b, we still need to substitute it back in to this part of the equation. So the equation is y equals 995x plus 15. Okay, we're not quite finished though. The question asks what would be the total fee after 10 months. But we want to make sure we're substituting 10 in the right place. Notice in both of these points, months were x. So this is an x value of 10. So we're going to substitute 10 in the equation for x. Y equals 9.95 times 10 plus 15. So this is 99.5 plus 15, which is 114.5, or $114.50. Okay. One thing I would like you to notice about this equation, this will make things a little easier to understand later, just so that this equation actually makes sense and it's not just these arbitrary numbers. The slope that we found of 995, remember, slope is the same as rate of change, so it's showing how much the fee is changing per month. Well, the video game website charges a registration fee plus a monthly fee. Hey, look at that. That $9.95 is the monthly fee. When we found the y-intercept, b, think of this, when you think of the y-intercept, remember that's where x is 0 on the graph. Well, if x is 0 and x is the number of months, that would be the charge for 0 months. Well, that sounds to me like a registration fee. You pay that no matter how many months you have this membership for. So the registration fee is paid as a flat fee, and then you also pay a certain amount per month. So this is the registration fee. And now this equation might make a little bit more sense. So you pay $15 for registration, and you also pay $9.95 per month. See how that all fits together? And then for 10 months, it's a charge of $114.50. Okay. For the last try it yourself problem, you have a very, very similar problem to example number 4. You have the cost of 7 half-hour piano lessons is $179. Cost of 11 half-hour lessons is $267. So you'll do the same thing we did. You'll first write a linear equation that shows the cost y for x half-hour lessons. That's basically this equation that we had here for this problem. So you'll have something similar to that. And then use the equation from part A to find the cost of 3 half-hour lessons. Just like here, we used this equation to find the total fee after 10 months by substituting 10. So go ahead and pause the video, work through the try it yourself problem, and when you're ready to check your work, press play. Okay, the equation that you should have gotten here should have been y equals 22x plus 25. Again, if you want to think about what that means, this $25 is basically what you're paying to to start piano lessons. It's like an upfront cost. This $22 is the amount per half-hour lesson. So $22 for each half-hour lesson, plus just a $25 fee to take piano lessons. And then for part B, use this equation to find the cost of 3 half-hour lessons. You should have gotten a total cost of $91.